basic one. I want to know the concavity. Now, where concavity switches is not called a critical number. But we're going to do the same thing. We're going to take the second derivative. We'll set the second derivative equal to 0. We'll solve for x. We'll plug those values into on the number line. And then we'll pick values and plug those into the second derivative. If the second derivative is positive, it's concave up. If the second derivative is negative, it is
concave down.
Concave down. All right, so let's just go with a basic one first off. I'm going to go with f of x equals to 2x squared minus 4x plus 3. All right? Now, I want to find the first derivative here. So what is the first derivative? Is this showing up, or do I need to turn the light off? That's good. 4x minus 4. I feel like a magician. That's not my sleeve. Except for a couple of guns. Alright.
Sorry, YouTube viewers.
We're checking for concavity. That's the whole purpose of what we're doing right now. Glad you've been paying attention. I won't name your name, Chris. Alright, so what is the second derivative here? 4. Alright. Now, let's solve 0 equals to 4. And what do we know about that? Never happens. No, actually, this would be a big happy face, because there's nothing to do here. So let's go back to it. Someone mentioned this earlier. What do we know about 4?
It's a constant.
It's positive, right?
I'm just kidding.
And if the second derivative is always 4, then the second derivative is always positive, which means this. Y'all are just beat me to asking the question. It's always concave up. Y'all are great. Y'all must have a good teacher.
We don't.
No. Because if this had been negative 4 right here. Yeah, any positive number, then it'll always be concave up. Yes. What? Alright. If it's 0, you're talking about a line. Let's look at that. Great question and great answer.
This is your answer, always concave?
Yeah, this function right here is always concave up. And think about this. What is this shape? It's a parabola, right? And what do you know about a parabola? Like this.
It's always
no,
concave
always
up.
Concave up, isn't it? Now, this stuff works. It's amazing. But let's talk about one where the first derivative is, the second derivative is going to be 0. And what makes that happen is a line. So we've got f of x equals to 2x plus 7. All right? What would f prime of x be?
2.
2. So, if f prime of x is 2, then what do we know about that line?
It's positive.
It's always, but what does positive mean in the first derivative? Increasing. So it's always increasing, right? So this line is always increasing, but you knew that. You knew that, hey, if we got a slope of 2x plus 7, then it's always going up.
But if the line isn't bent, can it be concave? Because it can't hold that.
I hope this line isn't bent. What's the second derivative?
0.
0, right?
Yeah.
F double prime of x is 0. So that means there is no concavity.
Yeah, that's what I meant.
And a line shouldn't have any concavity. When I draw it, it might have some concavity, but
Concavity is like holding water or whatever.
yeah, pouring water out. But that line would be 2x. There is no concavity there.
No cavities.
So what's your answer?
Hey, Coach Brent, so is that
person or please.
the answer?
You write no concavity.
No concavity. All right, what were you asking, Emily?
That was what I asked.
All right.
So, right now we're not looking at if it's increasing or decreasing.
No, we'll get to all that tied into one a little bit later, but for right now, we're just looking at concavity. Yes.
Alright, for 2x squared minus 4x squared. That, so you say that's one that's always concave up.
Yes.
How come that's not increasing? And you know how you say the 2x plus 7 is.
All right, let's look at this. If you go to this one, all right, you can tell that from here to here it's decreasing, right?
Right.
And from here to here it's increasing. Well, let's look at the first derivative here. Let's match them up. The first derivative, if we set it equal to 0, we get 4x minus 4, right? So that would mean that 4x equals 4.
And you get 1.
So x equals
That would be
1.
negative 4x because you moved it over.
Get picky.
Oh, yeah.
So x equals negative 1, right?
Dang, you got
Are we
called
good?
out. No, you added over.
You had to add it over.
You add, because it was already in.
There, yeah.
What?
Wait.
No, it's.
Okay, yeah, that's right.
Or you could just move the negative 4 over,
These,
and you just turn
I'm
into
satisfied.
positive.
Okay.
Good. I used to understand it, but now I'm confused. Everybody good? All right, so we put 1 on the number line.
Wait,
Right.
are we starting a new problem?
No, he just asked about, he did ask about the increasing and decreasing aspect of it. So I'm showing how we can get two different values here. Now, plugging in 1 on the number line, let's put 0 here and 2 here. What do we get when we plug in 0 to the first derivative?
Negative 4.
Negative, right? So it's decreasing. Yeah. What do we get when we plug in 2 here?
It's increasing.
Positive 4, right? So it's increasing. So,
And 1 is
see,
right.
here's an example where it's always going to be concave up, but here we're decreasing for a while and then increasing for the rest of it. Stuff works.
Can you zoom in a little
It's just
bit?
like, I mean, I could do an infomercial on this because it always works.